All right, gang, this is the very last part of Chapter 2. Up to now, we've been talking about how to design a study, how to collect data, how to analyze data, but now we need to know what all of our data means. To do this, we need to understand a couple of things. First, we need to understand that all of the measures that we would look at are imperfect. So whenever we conduct a study, our measures are samples from a larger domain. And what we hope is that if our samples are consistent and accurate and representative, then the inferences that we make from those samples will be trustworthy. But again, all samples by definition are imperfect. But what we need to decide is how much imperfection is okay to still trust our results. Well, we have a couple of good enough standards, and they are called reliability and validity. Reliability has to do with the consistency of a measure. Validity is never about numbers. It's more of a conceptual construct. So think about it as whether or not the accurateness of our inferences made from a test score are accurate, and whether or not we measure what we purport to measure. So let's take a look at the difference between reliability and validity by taking a look at a metaphor, and we'll look at the metaphor of darts. Obviously, the goal of darts is to hit the bull's eye. Because reliability is about consistency, if we consistently hit in the same place, regardless of whether we hit the bull's eye, then we have evidence of reliability. If, on the other hand, I hit the target, I have evidence of validity. So let's say that hitting the target represents measuring knowledge or skill in some area. And you're going to hear some noises here, guys, so just prepare yourself. So let's talk about the difference between reliability and validity. This measurement is not reliable or valid. If this were a test, you'd have a different score each time you took it because those darts landed in other places. So basically, we would have no confidence that the scores on that test reflect your knowledge or skills. Let's take a look at another example. Now notice in this example that all of the darts fell in the same place. So this measurement is reliable, but they didn't fall on the bullseye, which is what we were trying to measure, so this is not a valid test. If this were a test, we'd be able to predict your score, but we wouldn't have a clue what it was that we were measuring. Let's take a look at another example. Notice here that all of the darts hit in the same place, meaning that they are reliable, but also they hit the bullseye, meaning that we have validity. So if this were a test, we'd be able to predict your score, and we'd be confident in the inferences drawn about your knowledge or skills from that score. Now, there are a lot of different ways to determine reliability, and they basically involve taking measurements of two different variables and correlating the scores. And if those scores, when they're correlated, are high, then we have more evidence of reliability. So, for example, one way that we have to test reliability is called test-retest. What we basically do is we ask people to take a test at two different times, and then we correlate your scores. Again, if your correlation is high, we have evidence of reliability. Then there's another strategy called equivalent forms. Some of you guys may have actually been a part of this. This is where you take basically two versions of the same test. So you might have version A and version B. And again, you correlate your scores on version A and version B. If the correlations are high, then we have evidence of reliability. Another method for examining reliability is called split halves. What you basically do is you'll take one test and you'll split it up in a number of different ways. One way is to just compare the odds to the evens, but you might also be able to compare the first half to the second half. But it's actually preferable to compare the odds to the evens because sometimes people lose gas on the second half of the test and aren't able to do as well on the second half of the test as they do on the first half. So again, we correlate your scores on those two subsets of items from the same test. The most common way of examining reliability in the field of I/O is to use what we call internal consistency. This is a much more stats-heavy way of looking at reliability, and we use a measure called Cronbach's alpha, which basically finds and takes the average correlation between every single pair of items on a test. And you have to have a statistical program to do this, but this is pretty savvy, and this is what we commonly do. Finally, there is inter-rater reliability. This is where you will take a correlation between two different raters' judgments about a person, and again, you're looking to see if the correlation is high, and if it is, we have evidence of reliability. One thing that I want to drive a point home to you guys about is that the different methods of assessing reliability are simply different ways of getting at the same thing, and that is answering the question, is our measurement consistent? So we have evidence of reliability if our measure is consistent, and no one way of measuring reliability, whether it's split halves, whether it's Cronbach's alpha, or whether it's test-retest, is superior to any other. Now let's move on and talk about validity. Let's look at the following example. Imagine that we decide to measure the performance of a firefighter based upon the number of fires that he or she works to put out during the year. And let's say that the number of fires they put out decreases over time. Does that mean that they are a good firefighter or not a good firefighter? Well, let's answer a couple of questions. Is that measure, the number of fires, is that very accurate? In other words, does the occurrence of fires have anything to do with the quality of a firefighter? And number two, is it complete? What else do firefighters do? So firefighters also do things like rescue people, provide medical assistance, they maintain equipment, and they drive trucks, and they do a lot of other things. So that measure, the number of fires, whether it decreases or increases, is not very complete. There goes the noise again. This example gets at the concept of validity, a concept that can be tricky for many students to understand. Validity we like to think of as a unitary concept, and what I mean by that is that validity is simply answering the question, am I measuring what I say that I'm measuring? Another way to look at that is, do we have support that the inferences from our test scores support what it is that we're supposed to be measuring. In general, we have three strategies for collecting validity evidence. We have content validity, criterion-oriented validity, and construct validity. Regardless of what method you're using to establish validity evidence, most validity studies simply ask whether or not our assessments in IO psychology allow us to make good hiring decisions. So the basic hypothesis for these types of studies is whether or not performance on a test used for hiring, and this could be, for example, a cognitive ability test, whether or not that test and that performance predicts your performance on the job. Another way of saying this is that the test is, like in a correlational study, our predictor, or in an experiment, our independent variable. On the other hand, performance on the job would be our criterion or dependent variable if we were conducting an experiment. So using this example, does performance on a test, and maybe that test might be the cognitive ability test, on the job, predict performance on the job. One way that we can gather validity evidence is to collect criterion data, which in our case is job performance data. So what we simply do, again, like in the case of reliability, is we gather information about test scores and then performance, and then we correlate the scores. And again, if our correlation is high, then we have evidence of validity. So if it's strong and in the right direction, we have evidence of validity. The tricky thing about understanding criterion evidence is that there are two different types of gathering criterion evidence. There's predictive validity, criterion-related validity, and concurrent criterion-related validity. Let's talk about predictive designs first. With predictive designs, there's a time lag between when people take the test, and that might be the cognitive ability test again, and when you measure the criterion, and then in this case, again, it's job performance. What you typically do with this sounds a little strange, but what you do is you measure all of the job candidates with the test for a job, and you select them regardless of the test. So you're going to use something else to select them. And then maybe 6 months later, you obtain a performance measure. So you might ask supervisors for job performance measures, and then you're going to correlate their performance on the test and their job performance ratings. But some things you have to consider with this design is that it's kind of a dilemma if you want to hire everyone, and that's not necessarily a great decision if you want to hire all of those people who may not be people you want to hire on the job. Another option is to do what's called a concurrent criterion design. With this type of design, there's no time lag between when you take that test or the predictor and then when you collect criterion data, or in this case is job performance ratings. And again, what you do is you're going to test current employees on the predictor and then or that test, and then you're going to obtain performance measures at the same time. So you use existing employees, and then you ask their supervisors to tell you job performance ratings, and then you get a correlation between the test and performance. Let me give you, but one thing you have to consider though is whether or not current employees are the same as new hires, and obviously they're not, so that's one thing that you have to think about. Let me give you an example of one way we can do this. Let's say that we conduct an assessment center, and recall that an assessment center is simply a collection of tests, both individual and group. So let's say that we conduct this assessment center to select console operators, and we conduct this assessment to identify applicants who have the knowledge, skills, abilities, and other traits, or KSAOs, required to be successful as a console operator. And our assessment center is 4 hours, including personality tests, an interview, cognitive ability test, and a handwriting analysis. And let's say that this is the data that we find. On the left-hand side are our predictors, or our tests, okay? And let's say, again, that we have personality, interview, cognitive ability test, and a handwriting sample. On the right-hand side are 2 different types of criteria. One is training performance and job performance rating. So again, what we're asking is, does a personality test predict how well a person will do in training performance, and does a personality test predict how well people will do on the job in terms of performance? Remember, criterion data is simply getting the correlation between 2 variables. So we're asking whether a personality test can predict performance in training in one example, and whether a personality test can predict managers' ratings of job performance overall. And take a look at what we have here. Those ratings that you see in that light yellow, those are doing a pretty decent job because those correlations are pretty large. They range from 0.4 to 0.7, which is pretty good. Notice though that the handwriting sample gives you a correlation for training performance of 0 and negative 0.1 for overall job performance, which is pretty bad. And our science tells us this. You would not use handwriting to determine how well people would do in training or on the job. Moving on, another way to collect validity is to conduct content-related validity. By definition, what you're trying to do is you're trying to see whether or not a test is representative of the domain that you're trying to study. To do this, what you do is you collect a job analysis, and you basically talk to people who we call subject matter experts, and these are people who know the job, and you ask them about the most important parts of their job and frequently performed aspects of the job. And then what you're trying to do is you're trying to draw a logical connection between what the subject matter experts say is important and frequently performed on the job, and then your test. So for example, let's say that we're interested in developing a painter's job knowledge test. And let's say that the purpose of this test is to determine whether or not painters can be promoted to brush and roller painters based upon their knowledge of the job. And let's say we're interested in designing a 100-item multiple choice test. And what we want to know in order to collect content validity evidence is how many items should be devoted to each area of the job. So to gather content evidence for a painter's test, again, we would interview subject matter experts and ask them about the tasks in their job, how frequently they perform them, and how important they are to the job. After this, we come up with what is called a criticality index, and that is used to compute the number of items that will be on the final test. Based upon this information, looking at the slide, you can see that, for example, that preparing the surface and coating the surface are very much more important than, for example, cleaning up. And in this case, preparing the surface and coating the surface will show up with 43 items on the test and 29 items on the test, respectively. Unfortunately, throughout the years, construct validity became to be known as a type of validity. And you can blame that on a task force that was developed in the 1950s who said that there were three different types of validity. Just like reliability, there are several methods of gathering evidence to determine whether our inferences are accurate and complete. And again, no one method is superior to another. So construct validity can also be thought of as just the integration of evidence that assesses whether or not we're making correct decisions about psychological constructs. In other words, are we measuring what we're saying we're measuring, and are we predicting what we're saying we're predicting? So for example, using that same example that we've been using, performance on a test used for hiring and whether or not it predicts performance on the job, with construct validity, and it's all construct validity, what we're asking is the construct underlying the test used for hiring theoretically related to the construct underlying job performance? And that's all there is to that. I know that this is probably a little bit difficult to comprehend. I strongly suggest that you read over this information in your textbook. It is important to some of the other constructs that we'll be talking about later on in the class. But again, if you have any questions, don't hesitate to let me know. And I think we have it all covered. Take care, guys.